Okay, the checklist. This time we will write a Solidity smart contract that acts as a crypto bank. The contract will have the option to deposit either, withdraw either to own address and to other address, option to delete the account. The bank admin will have the option to find the VBIP customer of the bank, which means the customer with the highest bank balance. Also retrieve the bank balance of each account. Let us start by creating another contract file named uc2.so. Create the starting template and replace the version. Next, create a contract named CryptoBank. Within the body, we will create a mapping for account balance. Mappings are used to store data in the key value format. In our case, for any address, we can store the corresponding balance in numerical format. We will create another mapping, account ledger, to store all accounts created in the bank. This mapping will use sequential numbers as keys. Then we will create a variable to store the number of accounts ever registered with the bank. Then an address type variable that stores the address of the bank admin. Then we will define an event named deposit with two parameters. Solidity events are EVM log entries which enable asynchronous notification and indexed data querying for off-chain applications and services. So we will use it to log the account and amount when a deposit action happens in the bank. Next, we will create a modifier named onlyOwner. Solidity modifiers are reusable code snippets that can be attached to functions. They enhance their behavior by enabling pre and post condition checks and controlling the execution of the function body. So for our use case, we'll modify the behavior so that before executing a function, we'll check if the caller of the function is the address stored in the owner variable. Using this modifier, we can create functions that can only be executed by admin. The underscore semicolon is used to specify the function body execution point. So here, it will check the condition and then execute the function body. Here, the check is done using the require function. Now, if the function call fails due to the require condition not being met, then the transaction is still recorded on the blockchain, but any state changes are reverted, effectively canceling the action as if never happened. This also means execution cost for the checks will be consumed from the provided transaction cost and the rest will be returned. We'll also create another modifier with an input parameter named amount. This modifier verifies if the caller's account balance, as according to the account balance mapping, meets or exceeds the required input amount. After the check is done, execute the function body. We'll have a constructor to assign the owner value to the deployer address, which will be the admin address. Next, create a function called deposit, which will be public and payable. Within the function body, we will check whether it is a new customer by checking the balance of the caller's address within the account balance mapping. If the address has zero balance, we will assume it is a new account and add it to the account ledger mapping. Then we will update the balance of the address with the either amount sent along with the function call. Finally, we will log it using the deposit event. Next, we will have a function named withdraw. To withdraw money from the bank contract to the caller's address, we will tag it with the balance check modifier we defined earlier, ensuring the customer has enough balance to withdraw. So we can pass the input parameter directly to the modifier. The modifier will check as defined and then execute the function body. Within the function, we will reduce the account balance by the amount requested and transfer the requested amount to the caller's address. We can also create another function enabling us to withdraw balance to another account. We'll name it the same, withdraw, but with the different parameters. A payable address parameter will specify the address to which either is credited and the amount to be transferred. We are making use of the Solidity's function overload feature over here. This will have balance modifier in the function body. We will reduce the caller account balance, increase the recipient account balance with the requested amount, and finally transfer the amount. Then we will write another function named delete account, which will enable us to withdraw all the amount from the bank and delete the entry from mapping. So we'll find the caller's total balance and transfer it. Then we will delete the entry from the mapping using the delete keyword in Solidity. The delete keyword resets the variable to its default value, effectively removing its contents from the storage. Next, we will create a function to get the bank's balance. This function will be tagged with only admin modifier, which essentially means it can only be called by the admin. This will return the bank balance in way. We can get this using the address of this. This keyword points to the contract and then use the balance member function to get the Ether balance. Then we'll also create a function to get the caller address account balance. Finally, we'll create a function to find the bank's VVIP customer, simply the account with the highest balance. It can only be called by the admin and it will return the account address and balance of the address. The return variable are given names. This way, these variables can be used within the function and will return the final values of the variable. We don't need to use the return keyword. We'll loop through both the account ledger and account balance mapping. Let us create a temporary address variable. So we'll use for loop and we'll start from 0 till the account count. Inside the loop, we'll retrieve each address from the account ledger and check its balance. We'll check if the retrieved balance is the highest balance. If yes, we'll store it in the return variable. The loop will go through all the entries, and once the final loop is complete, the return values will have the highest balance and the corresponding address. That's it for the contract creation. Next, we'll deploy and execute it. Now, compile and deploy the contract. Let us deposit 4 Ether. Remix displays the contract balance in the top section. We can also use the function to get the bank balance and check it. We can also check our account balance. Now let us deposit 5 Ether from another address. We can check the account balance and it's updated. We can check the bank balance and it fails as we are not the admin account address. Also can't see the VVIP details. Let us switch to admin address and inspect the bank balance and VVIP account details. Now I can withdraw an amount, say 1 Ether. We'll specify that in way. Let us check the balance before withdrawing. So it is 95.9. Withdraw and now it is 96.9. Let us copy another address to check the other withdraw function. That address has 94.9. Use the other withdraw function and specify the amount and recipient address. Execute and check the balance. Now the balance is 95.9. We can also check the balance, which is now 2, as I withdraw 2 Ether. Also check the bank balance, which is also updated. Why don't you check the delete account function and see how it modifies the state? And that's it. Thank you.